In this video we'll make halftime in plugin script. So yeah, as you've heard, it still has some problems. So sorry for the clickbaity introduction. We will not make halftime in this video, but I will show you the script that made this thing happen. And even though it still has issues, I will put it into my PNS repository because it's a good starting point for resampler kind of things like that. That's why I call it wish time, because it's like ordering halftime at Wish. Yeah, as you've seen, what do we have here? We have a knob for the length of each grain. So how much of one bar is being taken to resample, like 1 bar or half a bar, or no, that's actually 2 bars, and this is half a bar because it's like the tuning speed, just like this knob. I decided that it has the same intuition, and that would make sense more than actually giving it the right value here. And tuning is, yeah, half time and double time and 4 times the time and 4 times less speed. Mix knob, easy peasy. Reverse, also self-explanatory. So yeah, let's just dive into it. So wish time, string description, and so on. Then we have the parameter names, as you've seen. And yeah, the mix one has percentage because it's from 0 to 100 actually, not normalized. And there is a length enum for the grain length in the tune. There I decided to just put a string here so that I don't have to write it out twice. And yeah, we also have a tune map that also has the same values but as doubles, so that we can use that in the code. And off on for reverse. Then the ranges, yeah, as you've seen, there are very strict steps on the grain length and tune thing, intermediate stuff, and an infinite intermediate stuff on the mix, and yeah, just 2 options on reverse. And I think that's all you need to know for now. Then there is a constant int resampler size, which has sample rate times 10, so 10 seconds. So basically that means if you run into a situation where any of this stuff, or at least the grain length stuff, has a longer time than 10 seconds, then the script would not work anymore. That would be an edge case that would make it crash. But I don't care, because that's very unlikely, unless you make really extreme music with your BPM. And I've not measured what kind of BPM would actually trigger that edge case, but I don't care. It is just a demonstrational script. But this is something that needs to be solved. Now, BPM, PPQ raw, and tune, some weird values here that will be explained later. Also these. But this is some parameter stuff. Then there is an object called sequencer, obviously, and there is an array of resamplers, and yeah, each channel has a resampler. Now let's go on with process block. So we get the BPM from the transport data, so this only works in DAWs that actually have transport information like the position and BPM, obviously. Then quarter note length, that is the length of a quarter note. So basically 60 divided by BPM is not beats per minute but beats per second, and then we multiply that with sample rate and we know the length of a quarter note in samples. Then PPQ raw is basically the position in quarter nodes, but we multiply that with 0.25 so that it's actually the position in bars, because I don't know who decided that this should be quarter nodes, and it's the same in JUICE. It's sort of a thing in audio programming in general, probably a VST specifications thing or something, but I don't like it. I usually tune stuff to a bar because that's something to work with. If someone knows why this was decided to put in quarter nodes, let me know in the comments or in a private message on Discord or something. Now bar length, that's 4 times the quarter node length, so that's what we will work with actually here, as you can see. So if the grain length parameter is not the input parameter, which is the case because it's -1, and you know the input parameter can be between 0 and 4, then it is now, and then the value is the tune map of int this. And you know, int is the rint function, which rounds something to the next integer, and then inting that so that it's actually the type integer, because this returns double. And then we can actually access the tune map, so we get some value out of this, like 421, 0.5, 0.25. And with this, now we can actually where do we use that? Oh yeah, here. We use it directly here. So bar length, the ratio between bar length and the grain length value can be used in the same sequencer as the grain length. In the sequencer, this information is used for 1 divided by grain length, and we get the increment value for the oscillator of the sequencer that we will see later with that. So that's basically how we define the speed of the sequencer. Now PPQ raw will be multiplied with grain length value here. I guess that's bad naming and not good code practice, because at this point it's not the raw PPQ anymore. Yeah, you should keep that in mind for your own code. Don't do this. Now the PPQ raw is multiplied with grain length value, and for that reason it has a different value now. It gets faster or it gets slower depending on if grain length value is actually over 1 or below 1. So when you turn this knob, then that has an effect on PPQ raw, right? So tune is also just the tune map on, but this time on parameter 1, input parameter 1. I don't know why I decided to not check here, because maybe I just generally wanted to do that here, or maybe it was because this thing also has this stuff in here, and it would be a bit more computation than just this. Anyway, tune, we don't use that here. We use that somewhere in here or in here or something. So let's not talk about that. But it is this, right? So using the second parameter causes tune to change. And then the mix value is the mix parameter times 0.01, which means that that we normalize it so that on the UI it looks like percentage from 0 to 100, but in code it's 0 to 1. And then the mix value is used on the resampler, on both resamplers with setMix. setMix on the resampler does the following thing. setMix. What? Oh yeah, resampler. I said resampler. I should listen to myself more. Now, if we go to Desmos. Oh, I don't have internet. My internet is lagging lately a little bit. Okay, so internet's back. Now I can finally go on here. So the setMix, it has a skirt 1 minus x, and it has skirt x, which means that if we put in a value between 0 and 1, then we get this. So we don't just mix the usual curve that just goes linear, so that when one of the things is 0.25, then the other one is 0.75, but we actually mix like this, so that we get a smoother signal on the intermediate values. Because usually when you don't do this, then things get too quiet. I feel like this thing actually makes it a slightly bit too loud sometimes, but it's still a better approximation than just going linear. Just so you know. So if you see mix dry and mix wet somewhere in this code, then that's it. Now let's go back. Where have we been? Oh yeah, setting mix. And then reverse is just whether or not the last parameter is over 0.5 or not. So it's probably 0 or 1, but I think this is safer to say than checking for 0 or 1 on a double. And yeah, now the actual processing starts. We have the sequencer, we process block, and then we have the process block resampler, which is basically resampling the block. And then everything is done. So let's go to sequencer process block. So we have the sequencer here. Sequencer has a buffer. Buffer length is max buffer size. You know what it is. It is 10 seconds. And set grain length, we have talked about that. We have process block, which is basically if the thing is currently playing, then we want to know where the current position is by getting the floor of the raw PPQ and then getting the fraction of that. And then that will be the value PPQ, the current position as a fraction instead of an absolute value, so that it will give us something in between 0 and 1. And the position and then information about the current position in regards to the grain length value, because as you know, we have multiplied PPQ raw with the grain length value, and that was the reason, because we want to use it here. And yeah, and then we process sample for each of these samples, which means that we, just like in any oscillator, just watch if PPQ is over 1, and if it is, then we put it back of 1, and yeah, we put it in here, and then we go on with the PPQ with the increment value that we have calculated from the grain length. And yeah, that's it. Then we have an oscillator that creates stuff between 0 and 1, and we can actually demonstrate that by calling the debug block method. Now I can just put a plug in here. Actually, let's turn on the volume, because we don't want to hear that, we just want to see it. Now we see that it kind of sends an impulse. Okay, I just paused the video because I was confused about something. I was confused about the impulse, because it looks like the thing sends an impulse, which is interesting, but it's kind of not true. And I was already suspecting that I made a mistake. But then I saw that the buffer actually sends the right values. If you see that, it's very small. Maybe I have to increase the size of the window. And now you see that I added a little print statement here for the buffer. So this is actually, since I put this into data samples, since I'm doing that, this should be not an impulse, but what is seen here. Now you can see when it's really fast, it's doing this, and when it's really slow, it's doing this. Or maybe it was because I have not played it back. Oh. Huh. No, it's because there is an equalizer here. Oh, I'm so stupid. Don't tell anyone. No, okay. I bet everyone sitting in front of their screens was already like, you fucking idiot. Or something like that. I would have too. Demonetized. No, just kidding. I am not monetized anyway. Speaking of which, this video is not sponsored by Skillshare. Skillshare is probably a very nice place, and if Skillshare sees this and wants me to annoy everyone by saying this video is sponsored by Skillshare, do this and do that, and then spend your money there and stuff like that, then give me money and I will do that. And if not, then you just not now know that Skillshare exists and that this video is not sponsored by it, which is a very valuable information. Okay, let's go back to reasonable things. So we see the sequencer here, right? So the sequencer can have different speeds. And yeah, whenever it hits the point where it says 1 and then goes back to 0, the goal is to reset the grain from the resampler later on. That's why we capture this sequencer stuff. And yeah, so if we have a fast value, then it will resync with the original dry signal often, which makes it stay near the present point way more often than as if it was very slow. And that's very useful if you put it on fast and then use a very slow pitch like this one. Then you still have a lot of the rhythmical stuff going on of your original signal, but you have the low pitch. And if you have a really high pitch, then and use a low grain length, then this would repeat the signal 1,000 times. No, not 1,000 times, but a lot. While not being resynced, and only after 4 bars it will be resynced. Yeah, so for high values it just makes sense to stay high with this thing anyway, and for low values you can do anything, and it will produce different interesting things. Now an important thing to note is that the tuning up stuff kinda does some weird stuff sometimes, so I'm not sure if it works correctly. And if you see the mistake later when we are at the part of the code where it happens, then feel free to tell me about it in the comments or in a private message on Discord or something, so that I can improve the quality of my PNS Fundgrube Repository. Now let's go back from debugging the block to process block resampler. Now the output is the sound again. Okay, great. I just wanted to hear the sound a little bit. Now we can go on with the actual code. Process block resampler. So we have seen it uses process block of the resampler array and then gives it the corresponding buffer of doubles and the buffer from the sequencer, and also an information about how many samples to process, which is needed because we don't give it the whole block data. And yeah, so now resampler. Resampler also has an internal buffer. I don't know if we actually, yes, alright, that's the ring buffer. So the ring buffer also has the resampler size +1. And oh, I think I said the same about the sequencer, didn't I? That is actually wrong. The max block size is a constant from plugin script that says that's the maximum size of samples that can be sent by the DAW currently, because the DAW sends a variable sized amount of samples per buffer on each process block except in Cubase. That's important to know. So when you want to make a buffer for stuff in your PNS application, then you need to know about max block size. It's a bit of a hidden feature. I had to ask the Blue Cat audio team for it. Now, resampler size is actually used on the ring buffer in the resampler. You see the one with the 10 seconds. And I also put 1 on it because I got some out of bounds issues for no reason. I know that PNS sometimes is a bit weird with values that are very close to a number. So when a value is very close, then in very rare situations, it anyway, it will go out of bounds for no reason. So just putting 1 on it, then it's cool. And I also have made a little size D double, so it's just the size but it's double because we use it a lot and I don't want to cast all the time. Set mix, you know it. So process block, we go through all the samples, we increment the write head, we increment the read head, and we process the sample. So incrementing the read head is just going on one sample, and if we reach size, then we go back to 0. Processing sample, I will skip the increment read head now because it's the most important bit. Processing sample is very easy as well. I mean, but we just put in our ring buffer at the write head the current sample, and into our current sample we put the mix dry times the dry sample plus mix wet times the wet sample, which is the spline interpolator doing something with the buffer at read head. So the spline interpolator is just this single function with the cubic Hermite spline interpolation code. Nothing special, it's the typical Hermite cubic spline interpolation code. An optimized version of it, because it's not very readable, but that's something that someone once came up with, and I got it from a friend. And very useful for things that should sound rather smooth. It's not the best interpolation method ever, and you can see some aliasing on some of the material that you process with it, but it's pretty good. So, and it's also computationally fast. That's important for a little test like this, because you want to know if the algorithm that you're doing or creating is causing issues, but you don't want the interpolation stuff to be part of the issue, because then you can't differentiate anymore what the issue is coming from actually. Okay, so that was easy. Now the increment read part, it gets the sequencer array and it gets the current sample information, and then it does its thing, which is a lot. And now before we go into it, I want to say that something about this is weird. I don't know exactly what it is. Something is just weird. And there is some issue. And if something that I say now makes no sense, then that's probably the issue. So let's just try to speak it out, and maybe I will find the issue while doing that. Now, first of all, there is a sequence div, which means let's pretend we are going through the sequencer and we have a value. So going through the sequencer, it can be something between 0 and 1, then it flips back. And then there is another value, which is the follower of the sequencer. And it can also go along here. But the follower will always be behind the sequencer. So sequencer minus follower is a positive number unless we are at the point where it goes like this. Then we are below 0. That's why I got the difference between the things, and said if it's over 0, then some stuff happens, and if it's below 0, then other stuff happens. And at the end, we put into the sequencer follower the current sequencer value so that this mechanic actually works. Now, what is the thing that happens on positive values? This is the path that is being taken when it should not reset, when it should just go on. And that's very easy. If we go in reverse, then the retard just decreases with the tune. And if it's lower than 0, then it goes up the size. And if it is not reversed, then we increase in tune. And if we go over size, we go below. So this part is definitely correct, I guess. Unless it's a typo that I just don't see because it's way too obvious. And now, what is happening when we actually have to reset? When we reverse the signal, we just put the read head equal to write head, because we can just start at the write head because we'll go backwards anyway. And yeah, that's cool. This works. This works really well, and I think that this is not the problem. The problem is probably this, where I decided to do this, saying read head is the write head position, so the present, minus the grain length value, because I thought to myself, if we just let it go from the write head, then it will overtake the write head immediately, if not in reverse, and then it will go to the end of the buffer with stuff that is long ago. It is like almost 10 seconds ago, so we don't want that. So we rather go minus grain length value so that it can start there, and then minus 4, because 4 is the size of the resampler, of the interpolator. But I guess that is not needed, and that's probably crap too. But anyway, if it's below 0, then we go up the size. This is definitely correct. But this is, I don't know, there must be a better solution than this, to be honest. But I will still keep it there because this is how it currently works, and it's kind of okay so far. And yeah, people who are interested in making something like halftime can use this as a starting point to get something done. And I think that's already a very valuable video, even if some of the things in the script have some issues, because I've seen a lot of people asking how halftime works in the time that I was programming already, and it was just like 2 or 3 years now. But really a lot of people ask that all the time, basically. So yeah, you can stop asking now and just enjoy getting somewhere from this point.